Bismillahirrahmanirrahim. Assalamu alaikum, dear students. It's your physics class, and we'll discuss in this class about the branches of physics. In the previous class, we discussed the five branches, which were mechanics, heat and thermodynamics, oscillation and waves, optics, and electricity and magnetism. Now, today we start from branch number 6, that is atomic and nuclear physics. Now, in this branch, we will study about the structure and properties of individual atoms and nuclei of an atom. For example, its examples are X-rays, lasers, nuclear reactor, MRI, CT scan, and PT scan. Now, one by one, we discuss that what are these. X-rays. An X-ray, rarely called X-radiation. It's a penetrating form of high energy electromagnetic radiation. Second is laser. Laser is a device that stimulates atoms or molecules to emit light at particular wavelength and amplifies that light and typically producing a very narrow beam of radiation. Nuclear reactor. It is formerly known as an atomic pile. It is a device used to initiate and control a fission nuclear chain reaction or nuclear fusion reaction. Nuclear reactors are used at nuclear power plants for electricity generation and in nuclear marine propulsion. Next is MRI. MRI is the abbreviation of magnetic resonance imaging. It's a medical imaging technique used in radiology to form pictures of the anatomy and the physiological processes of the body. MRI scanners use strong magnetic fields, magnetic field gradients, and radio waves to generate images of the organs in the body. Computer tomography, CT scan. A computerized tomography CT scan combines a series of X-ray images taken from different angles around your body and uses computer processing to create cross-sectional images, slices of the bones, blood vessels, and soft tissues inside your body. CT scan images provide more detailed information than plain X-rays do. PT scan. Positron emission tomography. It's a functional imaging technique that uses radioactive substances known as radio tracer to visualize and measure changes in metabolic processes and in other physiological activities including blood flow, regional chemical composition, and absorption. Now, these MRI, CT scan, lasers, X-rays, PT scan, these are commonly used in hospitals. Next is relativity. It is a branch of physics which deals with the study of moving objects, including very high speed and gravitation. Its examples are particle accelerator and nuclear energy. Now, what are particle accelerators? It's an apparatus for accelerating subatomic particles to high velocities by means of electric or electromagnetic fields. Next is nuclear energy. The energy released during nuclear fission or fusion, especially when used to generate electricity. Now, on the slide, you can easily see the picture of the nuclear energy which is used in the electrical power plant to produce electricity. Next branch is quantum physics. It deals with the study of discrete individual units of energy called quanta. Example, the atom and its parts. Now, discrete means individually separate or distinct. And quanta is the lowest particle of any or the tiniest particle of any substance at subatomic level. Next is particle physics. It deals with the properties and relationships and interaction of subatomic particles. Now, its examples are quarks, leptons, photons, and bosons. Now, what are these things? These are new for you. Now, quarks. Any of a number of subatomic particles carrying a fractional electric charge. Quarks have not been directly observed, but theoretical predictions based on their existence have been confirmed experimentally. Now, it's a type of subatomic particles. Leptons. Leptons, any member of a class of subatomic particles that respond only to the electromagnetic force, weak force, and gravitational force, and are not affected by the strong force. Leptons are said to be elementary particles, that is, they do not appear to be made up of smaller units of matter. Photon. What is photon? It's a piece of energy, has no mass, moves at the speed of light, acts like a particle, has momentum. The energy of a photon is quantized. Now, on the slide, you can easily see the example of the picture of photon. Bosons. A boson is a particle that is force carrier and function as the glue holding matter together. Glue means that is strongly attached. Now on the slide you can see the picture of boson, which is function as the glue which is attached. Next is cosmology and astrophysics. Now it is the branch of physics in which we deals with the study of origin, evolution, and eventual fate of the universe. That how the universe originate, what is its evolution, and what are the eventual fate of the universe. What occurs in the universe? Its examples are stars, galaxies, and black holes. Now, stars are formed from massive clouds of dust and gas in space. On the slide, you can see the picture of the stars. Gravity pulls the dust and gas together to form a protostar. And as the gases come together, they get hot. A star forms when it is hot enough for nuclear reactions to start. This releases energy and keeps the star hot. So, it is the definition of stars, that how the stars are built up. Galaxy. Now, a galaxy is a huge collection of gas, dust, and billions of stars. Or you can also say that it is the collection of stars or the combination of billions of stars and their solar systems all held together by gravity. It is called the galaxy. Black holes. A black hole is a region of space time where gravity is so strong. You can see that it is a region of space where gravity is a much more amount, so strong that nothing, no particles or even electromagnetic radiation such as light can escape from it. Now, it's the definition of black hole. Now, biophysics and medical physics. What is biophysics? Biophysics, it is a bridge between bio and physics. It is a study of biological systems and biological process using physics-based methods or based on physical principles. Or you can easily say that it is the physical interactions of biological process and application of physics help process such as prevention, diagnosis and treatment. Now, how essential is biophysics to progress in biology? Biophysics discovers how atoms are arranged to work in DNA and proteins. Biophysicists are discovering how proteins work. They use these protein structures for discovering how biological machines work in health and also in disease. So, therefore, it is called biophysics. That in this branch, every work which is done in bio, it is on the principles of the physics. Now, medical physics, simply put, the application of physics to medicine. Simply, we can define it. More formally, the applications of physical energy, concepts, and methods to the diagnosis and treatment of human disease. Now, three main avenues: diagnostic physics, nuclear medicine, and radiotherapy. So, it is all about medical physics. Now, its examples are MRI, CT scan, radio tracers, and conduction in living cells. Now, MRI, computed tomography scan. We have already studied in the previous branch that what is computed tomography and what is MRI. Radio tracers and conduction in living cells. A radioactive tracer is a chemical compound in which one or more atoms have been replaced by a radioisotope. Monitoring its radioactive decay, a radio tracer can be used to explore the mechanism of chemical reactions. So, it's all about the branches of physics. Now, I hope that these all branches are clear to you. Till the next class, Allah.